Hello everyone, my name is Yusen Wang and my student number is 2014-66494. My supervisor is Paul Spirakis. Today I'm going to talk about my specification and proposed design. Fire division has a long history. From the land distribution problem in the Bible to the cake division problem, in today's society, which enables all players to allocate resources in a fair way as the primary purpose of fair division. Since the fair division issue was formally raised, it has attracted various disciplines, including economics, mathematics, and computer science. Infiniteness is the most widely studied concept under the environment of fair division. Here introduces some concepts of fair division, although there are many open-ended problems in the calculation, existence, and interrelationship of these concepts. Among these concepts, we need to pay most attention to infiniteness up to one good, EF1, infiniteness up to any good, EFX, Pareto optimality, PO, and maximum Nash welfare, MW. What's EF1? EF1 is a concept of fair division introduced by Buddhist. In resource allocation, there may be situations where player I envy player J. However, it can be eliminated by removing a single product from player J. It's just a theory, not that the product is removed. What's EFX? EFX is an optimal concept for solving indivisible items in fair division proposed by Karin Arins and others based on EF1 algorithm. In resource allocation, if no player I envies player J after removing any atoms in player J's bundle, then this situation is EFX. Any pair of players removes the envy of each other after removing the minimum between them, which is different from EF1. Moreover, each EFX allocation is a special EF1 allocation, and the opposite is not valid. What's PO? If it's impossible to make one player richer without making another player poor in economics, this situation is called PO. What's MNW? Nash welfare, NW, is simply the geometric mean of the utility of the agents. The purpose of MNW is that it achieves a certain balance between the summum utility and the minimum utility. Although MNW itself is not a fair division concept, it's closely related to fair division and EF1. The purpose of this paper is to discuss and realize the existence of EFX allocations for two players with additive valuations and also for many players with identical valuations of the resources. Additive valuations means that each player's valuation of each group of goods is the sum of the value of each product in each of group. Identical valuations means that every player has the same valuation function. By valuation, we are referring to a function that specifies the value of each bundle that a player may receive. Look for a solution for EFX distribution while satisfying the PO, realizing the practical problem of fair division from a fairer perspective is our purpose. If we want to discuss EFX, we must know that there are two different cases of marginal utility, zero marginal utility and non-zero marginal utility. So, what is zero marginal utility? It means players don't like the products added to their bundles at all. And if we assume that adding products to the player's bundle can increase the player's value, and the player is satisfied with the addition of the product, then we call non-zero marginal utility. After research, we use Lax-Mean solution and Lax-Mean++ solution for the EFX distribution because it can be satisfied with achieving EFX distribution based on PO. Under the premise of considering non-zero marginal utility, for two players with additive valuations and multiple players with general and identical valuations, Lax-Mean solution can guarantee that PO is met under the condition of EFX allocation when the players can have the same valuation to ensure that the EFX distribution is generated. A modification of Lax-Mean is EFX. For two participants with additive valuations, we need to use the cut-and-choose protocol. The cut-and-choose agreement is defined for two participants and divisible commodities. Here, we make a simple adaptation of the cut-and-choose protocol. Let player 1 use the Lax-Mean++ method to divide the product into two parts, and then let player 2 choose one of the favorite parts. Although the implementation methods are different, they can all get PO to ensure EFX distribution. Splittit is a non-profit website of fair division. Split chooses the M&W solution when only additive valuations is considered and only guarantees that the final result is EF1 and PO. More importantly, Splittit is mainly for divisible commodities in actual situations, while the focus of this paper is more focused on indivisible commodities. Moreover, the Lax-Mean solution we choose can achieve EFX with only two players while guaranteeing PO, whether it's additive valuations, general valuations, identical valuations. Another reason is that Splittit only contains 5 types of questions: share rent, split fair, assign credit, divide goods, and distribute tasks, which are not so broad in terms of audience and scope of adaptation. Based on ensuring fairness, the Lax-Mean solution enables users to set parameters more flexibly according to actual conditions to achieve the purpose of solving actual problems. Splittit doesn't require the assumption of non-zero marginal utility, and our Lax-Mean solution will consider a win-to-win situation more closely. Here, based on the definition of EF1 and EFX explained above, combined with a practical example to explain the difference more clearly. This example also shows that the results obtained by the method used in this paper are more efficient and accurate than split. The example here assumes that two players have the same product value, and there are two players, player 1 and player 2, and three products are A, B, and C. The example given here is about additive valuations. The specific means is as follows. The value obtained by assigning product A to player 1 is 4. The value obtained by assigning product B to player 1 is 2, and the rest can be deduced by analogy. Based on symmetry, we assign product A to player 1. So, when can conditions reach EF1? M&W solution will maximize the player's utility, so player 1 gets product A and product B, and player 2 gets product C. This situation satisfies EF1 and PO, but not EFX, because if the product B is removed from player 1, player 2 will still be jealous of player 1. What situation will satisfy EFX? Assign product A to player 1 and assign product B and C to player 2 so that EFX and PO are satisfied. Here are all of the details about my FIP. The whole process is together with the explicit schedule or displays in the Gantt chart below. Here is my all of the reference. So thanks for watching.